Today, I'm not going to talk to anybody. Oh, hello friends. Whoops, I'm not going to talk to anyone. And you, Screeny. Don't you just try talking to me, okay? Hey, hello? I'm saying something. Oh, you Dumbo. All right, fine. You don't want to talk to me? Just don't. Hello, Kelsey. How are you? Oh, I'm fine. Thank you. At last you said something. Oh, don't be so confused. I was just teasing you. And whenever I tease you, you go blank. Why is that so? What are we here for? Of course, to study. How come you don't know this? Then shall we talk about our studies only? Oh, you are so boring. Always studies, studies and studies. We have already completed Chapter 1, Real Numbers. Now what? Chapter 2, Polynomials. Ah, very good. It sounds interesting. Let's just repeat what we have done in the previous chapter, shall we? Euclid's division lemma.
Second, Euclid's division algorithm.
Euclid's algorithm is a technique to compute the highest common factor, HCF. That is, A is equal to BQ plus R, 0 less than equal to R less than B, where Q or R can be 0 also.
Third, the fundamental theorem of arithmetic. The fundamental theorem of arithmetic states that every composite number can be expressed as a product of primes, and this factorization is unique except for the order in which the prime factors occur. And some theorems. 1. If P is a prime and P divides A square, then P divides A, where A is a positive integer.
If P is a prime and P divides A square, then P divides A, where A is a positive integer.
And root 2 and root 3 are irrational.
Root 2 and root 3 are irrational.
Fifth, decimal expansion of the rational numbers which are terminating.
Decimal expansions of rational numbers which are terminating.
Decimal expansions of rational numbers which are non-terminating.
Decimal expansions of rational numbers which are non-terminating. Oh, hello ma'am. How are you?
Oh, hi Kelsey and hi Screeny. Hello everybody.
Ma'am, what are we going to do today?
Let me ask you something, Kelsey. Do you know something about algebra?
Algebra.
Okay, algebra is a branch of mathematics which deals with numbers and alphabets. Have you heard something about algebraic expressions?
Algebraic expressions?
Yes. If you recall, in 9th standard we have done something like algebraic expressions. Algebraic expression is a combination of variables and constants. If ax square plus bx plus c is equal to 0, then a, b, c are constants and x is a variable which varies. So today, Kelsey will start the new chapter called Polynomials using the terminology of algebraic expressions. If px is a polynomial in x, the highest power of x is px is called the degree of polynomial px. For example, if we take 4x plus 2, here 4 and 2 are constants and x is a variable. The power for x is 1. So we say it's a polynomial of degree 1. Now children, polynomials can be of 3 types, with degree 1, degree 2, with degree 3. The polynomial with degree 1 is called linear polynomial, and the polynomial with degree 2 is called quadratic polynomial, and polynomial with degree 3 is called cubic polynomial. So we define a polynomial of degree 1, that is 3x plus 4, is called linear polynomial. A polynomial of degree 2, that is 2x square plus 3x minus 2 by 5, is called quadratic polynomial. Next, a polynomial of degree 3 is called cubic polynomial, that is 3x cube minus 2x square plus x minus 1. So, in general form we can say ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers and a is not equal to 0. Kelsey, did you get what I mean to say?
Yes, ma'am. A polynomial of degree 1 is called a linear polynomial. For example, 3x plus 4. A polynomial of degree 2 is called a quadratic polynomial. Example, 2x square plus 3x minus 2 upon 5. A polynomial of degree 3 is called a cubic polynomial. For example, 3x cube minus 2x square plus x minus 1.
Fine. Now children, shall we proceed?
Ma'am, but how do we find the values of these polynomials?
Yeah, good question. We can find the value of polynomials, that is, if px is a polynomial in x and if k is any real number, then the value obtained by replacing x by k is px, is called the value of px at x is equal to k and is denoted by pk. Now children, let us take one example for finding value by placing x is equal to 1 in a linear polynomial, that is 3x plus 1, we replace x by 1. 3 multiplied by 1 plus 1 equals to 3 plus 1 equals to 4. Now children, let us understand by replacing it in a quadratic polynomial, that is, we take px is equal to x square minus 3x minus 4 at the value of x is equal to minus 1. Since it is a negative number, we put them in brackets. P minus 1 is equal to minus 1 whole square minus 3 minus 1 minus 4 equals to 1 plus 3 minus 4 equals to 0. Now the polynomials whose values are 0 are called zeros of the polynomial. So the polynomial with degree 1 will have 1 0 and the polynomial with degree 2 will have 2 zeros and a polynomial with degree 3 will have 3 zeros. We will understand this in the later part of the chapter.
Ma'am, what do we mean by zeros of a polynomial?
Yes, let us understand this. A real number k is a zero of polynomial px is equal to 2x plus 3. Then the value pk equals 0 gives us 2k plus 3 equals 0, or we can say the value of k equals to minus 3 by 2. If k is a zero of polynomial px is equal to ax plus b, then polynomial pk equals to ak plus b equals to 0. That means that the value of k is minus b upon a, that is 0 of linear polynomial ax plus b is minus b upon a or minus constant term upon coefficient of x. So students, let us understand this by taking some examples. Find the value of quadratic polynomial fx is equal to 2x square minus 3x minus 2 at x is equal to 1 and x is equal to minus 2. Fx is equal to 2x square minus 3x minus 2. We find the value of f1 equals to 2 1 square minus 3 multiplied by 1 minus 2 equals to 2 minus 3 minus 2 equals to 2 minus 5 gives you minus 3. So the value of f1 is minus 3. Now let us take the value of minus 2. That is, we place the value of x as a negative number minus 2. So f minus 2 equals 2 in the brackets minus 2 whole square minus 3 in the bracket minus 2 minus 2 equals to 2 multiplied by square of minus 2 is 4, minus 3 into minus 2 gives you plus 6 minus 2, which gives you 8 plus 6 minus 2. 8 plus 6 is 14 minus 2 gives you 12. So value of f minus 2 is 12. In this way we can place any values of x and find out the value of a polynomial. So now children, let us take one example of cubic polynomial. Find out the value of polynomial by placing x is equal to 2 and x is equal to 1. Polynomial px is equal to 3x cube minus 2x square plus x minus 1, which is a cubic polynomial. Now we take the value x as 1. So p1 equals to 3 multiplied by in brackets 1 cube minus 2 in the bracket 1 square plus 1 minus 1, which gives you 3 multiplied by cube of 1 is 1 minus 2 multiplied by square of 1 is 1 plus 0 equals to 3 minus 2, which gives you 1. So the value of p1 is equal to 1. Now we put x as 2. So the polynomial 3x cube minus 2x square plus x minus 1, we are putting x as 2. So p2 equals to 3 in the brackets 2 cube minus 2 in the bracket 2 square plus 2 minus 1, which gives you 3 multiplied by cube of 2 is 8 minus 2 multiplied by square of 2 is 4 plus 2 minus 1 equals to 24 minus 8 plus 2 minus 1. Now we add positive numbers together and negative numbers together. So we get 24 plus 2 26 minus 8 minus 1 gives you minus 9. So we get 26 minus 9, which gives you in turn 17. So the value of p2 is 17. That is, the value of cubic polynomial at x is equal to 1 is 1 and at x is equal to 2 is 17.
Ma'am, can I ask you a question?
Yes, go on.
Ma'am, why are the zeros of the polynomial so important?
Yes, to understand it, the geometrical representation of linear polynomial and quadratic polynomial, we need to represent them on a graph paper. Now, this is a graph paper and this is a roll-up board on which we can represent the graph.
Ma'am, how do we represent a polynomial on the graph paper?
Yes, Kelsey, to plot a graph, we need to first find out the values on the table. That is, if we take a linear polynomial, y is equal to ax plus b, example is 2x plus 3 is a linear polynomial. We are putting the values of x like 0, 1, 2, minus 1, minus 2, so that we get the values of y. First of all, we put x as 0. So y is equal to 2x plus 3 becomes 2 multiplied by 0 equals to 3. We get the value of y as 3. Now we take x as 1. So y equals to 2 multiplied by 1 plus 3, which gives you 2 plus 3 equals to 5. That is, for the value of x as 1, we get the value of y as 5. Now let us take some negative numbers, that is x is equal to minus 1. So by putting this value in the equation y is equal to 2x plus 3, we get 2 in the bracket minus 1 plus 3 equals to minus 2 plus 3 equals to 1. So for the value of x is equal to minus 1, we get the value of y is equal to 1. Now we take one more value, x is equal to minus 2. So in the equation y is equal to 2x plus 3, we put x as minus 2. Y is equal to 2 multiplied by minus 2 plus 3, which gives you minus 4 plus 3 equals to minus 1. So for the value of x as minus 2, we get the value of y as minus 1. So in the form of a table, we can put these values and we get x as 1, 0, minus 1, minus 2, and we get the values of y as 5, 3, 1 and minus 1 respectively.
Ma'am, we got the values, but how do we plot them on the graph paper?
Yeah, sure Kelsey, I'll show you how to plot them on the graph paper. Children, this is origin, this is x-axis and this is y-axis. Now we see that the graph is divided into 4 parts. So this is called quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. In this, we see the values of x are positive and here the values of y are positive. In quadrant 2, the values of x are positive but the values of y are negative. In the quadrant 3, both the values are negative for x and for y. In the quadrant 4, values of y are positive but the values of x are negative. So this is quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Now when we are plotting the graph, we need to take a linear equation y is equal to 2x plus 3. The values we got for x is equal to 0 and y is 3. So here we put the numbers 1, 2, 3. This side negative, minus 1, minus 2 and minus 3. For y, 1, 2, 3. For negative side we had minus 1, minus 2, minus 3. Now children, for plotting the values, we take 0, 3, x is 0 and y is 3. So we put a plot here, that is 0, 3 and we write 0, 3. So in this way we can plot all the points on the graph paper and let us see what is the position of the points. So children, after plotting all the points, let us join them. Is it coming a straight line? Yes. So, a linear polynomial can be represented on a graph as a straight line. So Kelsey, what did we learn today?
Polynomials,
Yeah, polynomials are algebraic expressions.
degree of polynomials,
Yes, the highest value of x in the polynomials is called the degree of the polynomial.
value of polynomials,
Yeah, the value of polynomial is given by minus b by a, that is minus the constant term upon the coefficient of x.
plotting points,
On a graph paper, you learn how to plot a points.
linear polynomials.
Yeah, linear polynomials with the degree 1. Linear polynomials graph is always a straight line. So today we learn how to plot a graph of linear polynomial which is always a straight line and cuts at the x-axis on only one point.
Ma'am, this looks complicated, but it is not actually. It is easy.
Yeah, Kelsey, it's very easy to plot points on the graph. So next time we'll see how to plot quadratic polynomials. Yeah, Kelsey, it's quadratic polynomial with degree 2.
Okay, ma'am.
Yeah. Okay, see you next time, Kelsey. Bye, Screeny. Bye-bye, children.
Bye-bye, ma'am.